Hey guys, it's Mr. Brian here. In this video, I'm partnering with EduKaji to guide you on the 2025 SPM Physics paper. We'll be looking at paper 1 on the objective questions today. Without further ado, let's get started. Okay, paper 1, 1 hour 15 minutes. Question 1. Which of the following quantities is correct? They love to ask base and derive quantities. And you must know all your 7 base. There's only 7, and you must know all your 7 base quantities. Like length, mass, like the most basic one. Length, mass, time, temperature, electric current, luminous intensity, amount of substance. These two especially are the ones people usually forget. Yeah, these are base quantities. So current is wrong. Current is supposed to be base. Amount of substance is base. Volume is not a base. Yeah, because volume is length times length times length. You derive. Derive means you create it from something else. Answers donkey. Luminous intensity. Okay, question 2. Diagram 1 shows a dog removing water from its fur. So usually they shake their body to remove water. Which of the following physics law is correct to explain this situation? Guys, this is inertia. Inertia, and that is Newton's first law of motion. Why? As the dog shakes his body, the water has a tendency to remain at rest. The water is resting at first, but when the body of the dog shakes, every time you shake, the water wants to rest, but the body moves. So the water will get removed from the body of the dog, from the fur. Yeah, so that is inertia. Answers A. Okay. Inertia is talking about how everything has a tendency to just keep resting. Like it wants to stay at rest, or it wants to keep moving in a straight line at constant velocity. Like for example, when we are in a car, we keep moving forward, and then suddenly we step on the brakes, our body will get thrown forward. Our body want to keep continuing forward. Yeah, anything like that is inertia. Same thing here. By the way, Newton's second law of motion is talking about F equals to ma. Newton's third law of motion is talking about action and reaction. Usually this one we are talking about how when you hit something, there is a reaction. Usually you will see this in impulsive force. Okay, action and reaction, you can also see it in explosions. In your principle of conservation of momentum, explosion. Yeah, like rocket. And exhaust gas. Exhaust gas shoot backwards, rocket will shoot forward. Yeah, there's action, reaction. Newton's universal law of gravitation is talking about gravitational force, where the product of masses of two bodies directly proportional to this gravitational force, and also inversely proportional to this r squared, to the distance squared. Okay, answers A, clear winner. Number 3, diagram 2 shows the glass slipping from a hand. Okay, slip off from your hand and it's gonna fall down. They ask, which of the following statement is correct about the type of motion of the glass? Answer is uniform acceleration, because when it fall down, it is free fall. And the acceleration is the gravitational acceleration, 9.81. Okay, it's not getting fast. It's getting faster and faster, but it's uniform acceleration. It's a fixed acceleration value. By the way, this is the same thing as velocity increase uniformly. It's getting faster and faster and faster very consistently. Yeah. Okay, question 4. Diagram 3 shows a paintball bullet with mass of 3.6 gram is shot with a velocity of 90 meter per second from a rifle with mass of 2.24 kg. What is the recoil velocity of the rifle? The rifle is 2.24 kg. The bullet is 3.6 gram. And it is moving with a velocity of 90 meter per second. Okay. This is an explosion situation. according to the principle of conservation of momentum, the total momentum before must be equals to the total momentum after the collision or after the after the collision of or after the explosion. So look something like that. But before we shoot the bullet, nothing is moving. The bullet is not moving. The rifle also not moving. The bullet is just inside the rifle and nothing is moving. So therefore, since no initial velocity at all, for explosion, we like to say the before is 0. After that, the bullet will shoot forward and it has a mass of, don't use 3.6 gram, we use SI unit, we use kg. So that will be 0.0036 kg. We divide by 1,000. Be careful with that. And it has a forward velocity of 90. Okay, so by the way, I'm considering this as a positive 90 because it's going forward. Recoil meaning it will move back. When you take a gun and you shoot something, it will move back. It will move back. And this velocity that moves to the back is what we want to find. Okay, so a lot of people will say, teacher, if it moves back, then I should put negative V. Am I right? No, you do not put negative V. So for an unknown, this is how you write it. The M2, the mass of the rifle is 2.24 kg, yes. Okay, but as it moves back, you put it as a V only. Okay, you put it as a V only. Why don't need to put negative? Because later on, this V will own self have a negative value one. Okay, let's call this V2. So your job is to find out later is negative what? The negative will own self appear one. If it's supposed to be negative, it will own self appear later. Okay, so for unknown, you don't have to put the negative sign for it. It will appear on its own. And then this is, of course, forward. So we're thinking forward is positive, backward, recoil backward is negative. Okay, so we're going to find out what is the V value. 0.0036 times 90 is, I do very slow now, this one 2.24 V, and then you move the 2.24 V over here, you get a negative. Then V equals to, okay, you type this out in your calculator, divided by negative 2.24. I get negative 0.145 meter per second. Okay, it's actually 1.446 meter per second. Yeah, so number 4 answer is donkey. The best answer is donkey. Okay. Okay. Principle of conservation of momentum. Question number 5. Residents of a cluster terrace house receive higher heat effects compared to normal terrace house. Cluster usually is like they have houses that stick together, like cluster together. Okay, what is the appropriate modification used to reduce the hot temperature in cluster terrace house? Reduce hot temperature. Use construction materials that have, okay, they are all the same. Looks like it's all talking about construction material, just either low specific heat capacity or high specific capacity. And then C and D is low specific latent heat and high specific latent heat. Okay, at least we know what we are dealing with. Confirm the answer cannot be C or D. Because if we talk about latent heat, it has to be phase change. Okay, it has to be talking about phase change. But the construction material never change phase also. It's just solid concrete. Yeah, you know what I mean? And so it has to be either A or B. Now this one is testing on whether do you know a low C value means it's very, very fast. Take a very, very short time to heat up. Take a very, very short time to cool down. A high C value, high specific heat capacity, take long time to heat up. Take long time to cool down. A shorter time, very fast, meaning it is a good heat conductor. A little bit of heat, that means the time taken very little, very little time, very fast. You heat up a little bit, it becomes hot. So if your house has good heat conductor, low specific capacity, when the sun heats it up, it becomes hot very fast at becoming hot. So therefore, guys, we need something like this in B, where it takes a long time, very slow at heating up. The sun keep on heating, it takes long time to heat up. This is what we call as a good heat insulator. In paper 2 also the same. If I ask you why do you want high specific heat capacity, you just say because it is a good heat insulator. If I ask you why do you want low specific capacity, you say because it is good heat conductor. So you must know this idea, this concept very, very well. Okay, so answer is boy. Takes long time to heat up, so won't be so hot, reduce the hot temperature. Okay. Question 6. Hydraulic jack. What is the modification done so that we can lift a car with a greater mass? This is Pascal's principle. Suddenly, we are in Form 5, Chapter 2. Yeah, Pascal's principle. Okay, we got small piston right here. And then the large piston is the one to push the car up. Increase surface area of big piston. That's true. If you got bigger area, okay, let's call this A2. If you got bigger A2, then you will have bigger F2. Yeah, the output force depends on the output area, that surface area there. Increasing volume of reservoir. You got more volume, then you can eventually move it higher. But if I want to move something with more mass, the volume just doesn't have direct relationship with being able to lift something heavier. Okay, use a smaller input force, confirm wrong. Yeah, you need bigger input force if you want to lift something heavy. Use fluid with low density, also not directly related. Yeah, usually we want something with low compressibility, something incompressible, so that when I apply a force, the pressure can be transmitted uniformly throughout. That's the whole idea of Pascal's principle, right? Answer is A. Okay, if you want to further look at, because Pascal principles say, right, that your pressure is always the same. And pressure is force over area. Now, you can also go and rearrange this formula so that you make F2 the subject. Okay, so I multiply A2, I get F1 times A2 divided by A1. This tells you that when A2 is bigger, you get more output force. Or when A1 is smaller, you get more output force as well. Okay, so you can adjust the A1 and the A2, the input and the output force, output area, sorry. Assuming your F1 is fixed, assuming if this one constant, this is how you can adjust your F2. Okay, question 7. Diagram 5 shows an athlete of hammer throw game in a circular motion. Which of the following shows the correct direction of centripetal force? Centripetal force is like this. Always pointing to the center. If they ask, what is the direction of the linear speed? Linear speed must be like this. Or if it's here, it will be like this. It's tangent to the circle one. Yeah, tangent to the circle. Okay, can right, answer is B. This one they try to confuse you. Normally this is the linear speed, so wrong. Yeah. This is also linear speed. Depending on which way are you spinning. Yeah, it can be A or C if it's linear speed. Okay, but answer is boy. Some people will go and draw outwards. Careful, centripetal force must be pointing in. It keeps on pulling you in. That's why a planet, for example, cannot escape. Like the moon cannot escape the earth. How come? Because the moon keep on being pulled by the earth. Okay, the earth also pulling the moon actually, but for centripetal, it is to the center only. And question number 8. Diagram 6 shows planet X orbiting the sun at 3 different positions, M, N, O, P, Q, R. The time interval for the planet to move at 3 different positions is the same. Okay, this is valuable information. Time interval at 3 different positions is the same. Same time. Which of the following statement is correct? Immediately, I'm thinking same time, same area. Okay, the linear speeds will be different. The speed, same time does not mean same speed. Okay, same time does not mean same speed. Same time just means it takes the same amount of time, but sometimes, guys, let's say the time is 30 days. I take 30 days to go from OP, QR, and NM or MN. Okay, but you see in 30 days, this one need to travel much more. For QR here in 30 days, this one need to travel much less. Like the distance travel is different. The distance is different, therefore the speed is different. Okay, the time is the same. This is called Kepler's second law. Okay, I like to tell my students, Kepler's law, you just think about the pineapple. Eat a pineapple. Okay, Kepler's first law is talking about elliptical orbit, saying that the shape is an ellipse shape, elliptical orbit. Okay, maybe I write elliptical orbit. Okay, A is area. If they say the area is the same, the time taken is the same, which is whatever this question is talking about. And P is talking about period, where we say if your orbital radius is greater, then your orbital period will be greater. T squared is directly proportional to R cubed. Yeah, so make sure you know your 3 Kepler laws. Yeah. Okay, question 9. Study the following statement. An object takes a longer time to cool. Ooh, I like this. Longer time to cool. Which of the following is correct to explain the statement? Latent heat. Oh, I don't think so. It's latent heat. I think it's heat capacity. Well, very easy. If you know it takes long time to cool, it means it is bigger specific heat capacity. But if don't have specific capacity, heat capacity also can. It works the same way. High heat capacity. Okay, that means take long time to cool, take long time to heat up as well. It works both ways, cool and heat up. Okay, latent heat is take long time to change phase. To change solid to liquid, liquid to gas. That one is latent heat, change phase. Heat capacity is to heat, to cool down, heat up, that kind. Okay. Question number 10. A metal with a mass of 0.5 kg is heated until temperature reaches 300 degrees Celsius. If the heat supplied is 42 kilojoules, what is the initial temperature of the metal? Okay, we have mass. We have temperature reached 300 degrees Celsius. Heat supplied is 42 kilojoules, that is Q. What is the initial temperature? So let's say it goes from a temperature called theta, and then it becomes 300. Okay, our job is to find out what is this initial temperature theta. Okay, so according to the formula, Q equals to mc theta. By the way, this is the C value. You can find this formula in the formula sheet. The Q is 42,000. 42,000 joules. That's what kilo means, huh? Kilojoules. Kilo is 1,000. Or you want 10 to the power of 3 also can. The mass 0.5 kg. That's SI unit. The C value is 300. You know what? Maybe I don't want to confuse you. Let me call this X. Okay, so it goes from a X degrees Celsius to 300 degrees Celsius. So the theta, the temperature is 300 minus X. Okay, we are looking for X. Why not X minus 300? Because you heat up. You must always take the bigger value minus the smaller value. In Q equals mc theta, we do not take negative temperature change. We only take positive. So it's always big minus small. From a low become a high temperature. You take the bigger one minus the smaller one, always. Okay, then you try to solve this. Got many ways you can do it. Some people, if you're very good, you know how to move this over first. You feel confident about it, go ahead. That's the fastest way actually. If not very sure, well, we can multiply. This one times this is 150. Okay, you can times in the 150. I feel it's even faster if you can divide the 150. Up to you how you want to do it. Okay, so let's say I do the most straightforward method, 45,000. I multiply in 150 and I multiply in, okay, and then you minus 42,000 minus 45,000. I get, oops, negative 3,000 equals negative 150x. X would be negative 3,000 divided by negative 150. You get 20. Okay, x equals to 20. The maths, don't worry about it. You do your own way. What is important is the first step. See whether you understand this. Okay, so don't rush into putting temperature 300, then you cannot get anything in it. You want to find the initial temperature. It goes from x to 300. You always need to sub in the change in temperature. That is the theta. Okay, theta is the change. Question number 11. Diagram 7 shows a piston of a syringe pushed by a force. It is found that the reading of the pressure gauge increases. Which of the following gas law is correct to explain the situation? Well, there's one thing that doesn't change in this question, temperature. The pressure increases. The volume, when you push, the volume will decrease. Yeah, but temperature is constant. Now, I always tell my students, best thing Charles planted was green vegetables. The best thing that Charles planted was green vegetables. Boyle's law, temperature is constant one. Charles' law, pressure is constant one. Gay-Lussac's law, volume is constant one. So, guys, pressure change, volume is changing in this question. Only temperature never change. Confirm is Boyle's law. Okay, B is Boyle's law, C is Charles' law, G is Gay-Lussac's law. Answer is B. Best thing Charles planted was green vegetables. Okay, that's how I teach my students. Yeah? Answer is Boyle's law. Okay, number 12. Diagram 8 shows an experiment to show the evaporation causes cooling effect. What happens to the ethanol when air is blown into it? Okay, so he's not drinking the ethanol, yeah? You're blowing air into the ethanol. When you blow bubble into the ethanol, it helps to evaporate it faster. But in your head, you need to think evaporation means that liquid becomes gas. You are absorbing heat. More specifically, latent heat. Because change phase, and it will give a cooling effect. Later I'll explain why is it cooling effect. Okay, so what happens when the ethanol is blown? What happens to ethanol when air is blown into it? Okay, we want to say that it absorbs latent heat. That is the best answer. Ethanol molecules release latent heat of fusion to form bonds. Okay. If you look at all the options, they talk about latent heat of fusion and vaporization. They also say to release heat or to absorb heat. So that's something we want to decide on. And also they mention to form the bonds or to break the bonds. Okay. Definitely not fusion, because fusion is solid to liquid. or liquid to solid. So A and B up. Okay, vaporization is liquid to gas or gas to liquid. Another thing, I already told you that if it's evaporation is liquid become gas, you need to heat it up. You need to absorb heat, then only it can heat it up. So it is absorbing heat. The ethanol need to absorb heat, then only can evaporate. Okay, and when you absorb heat, you will break bonds because the liquid molecules will break and become gas. Yeah, answers donkey. Okay, but why do we get a cooling effect? Because I told you, absorb heat. The ethanol absorb heat from who? From where? Absorb heat from the surrounding. So the surrounding, the outside of the cup will feel a little bit colder. It keeps on absorbing heat from the surrounding. So the outside of the cup will feel a bit colder. And when it's colder, a lot of water vapor will condense on the surface quite easily. That's why you will have water outside, like you see water. That's why your cold drinks always have water vapor outside one. It will condense that water vapor and it will stick on the cup, and then it will have this cooling effect because the drink keep on absorbing heat. Yeah, keep on absorbing the heat. So outside here is colder a bit. Okay, that is the idea for question 7. Yeah, or you can think the surrounding is losing heat because the ethanol keep on absorbing the heat. Yeah? Okay, question 13. Diagram shows electromagnetic spectrum. Which of the following matches is correct between wavelength and frequency? I normally tell my students real money is very useful. Real money is very useful and extremely good. Real money is very useful and extremely good. Okay, now knowing the order is one thing. You must know who is the longest wavelength. R is the longest. Radio wave, microwave, infrared, visible light, ultraviolet, X-ray, gamma ray. Longest wavelength. The one with the longest wavelength also means it is the one with the lowest frequency. The one with the high, so is the balik one. So one side is wavelength very high, the other end is wavelength very, very short. One side frequency low, the other side frequency very high. So for me, I just memorize one. You must memorize long wavelength radio wave. Okay, same thing for your rainbow colors, by the way. Your red, orange, yellow, green, blue, indigo, violet. Yeah. Again, red color is the longest. Yeah, red color is the longest. I always tell my students it is a coincidence that both the letter R, they are the longest wavelength. Yeah. And so I can ask you K-Bud question. Which rainbow color here is the one that diffracts the most, can diffract the most? The one with the longest wavelength can diffract the most, red color. Red color can diffract, can spread the most. Yeah. So you have to know your wavelength. Okay, so radio wave, microwave, infrared, visible light, ultraviolet, X-ray, gamma ray. Okay, we focus on the question. Gamma ray, maybe we do wavelength first. Gamma ray has the smallest lambda, and then it gets bigger and bigger and bigger. Okay, gamma ray also have the highest frequency. Okay, so this is low frequency to high frequency. Okay, I think can already. The question is quite tricky because the arrow, they put the balik like that. Yeah, so you have to be careful. Okay, so gamma ray from smallest lambda, it gets bigger and bigger and bigger. It increases. Small lambda here become bigger lambda. Okay, increase wavelength. And then frequency, from here to here, it is lower frequency to higher and higher and higher frequency. again increase the frequency. So you have to be careful, you have to see the arrow. They don't want to ask so direct on the question. Okay, so both also increase actually. Increase. P to Q, R to S. Answer is A. Okay, question number 14. Diagram 10 shows a spring with load experience loss of energy when the load oscillates up and down in water. Which of the following situation shows the situation to occur? When I see this loss of energy, I already know it has to be damping. Yeah, damping, you will lose energy and your amplitude also will reduce. So as it bounces up and down in the water, because got a lot of water friction and also got the spring, the spring always wants to go back to the original shape and size. Yeah, so it's the system lose energy a lot and eventually it will stop. That's called damping. Okay. Damping, you will see the amplitude decrease like that. Yeah, you will see the amplitude decrease like that. Here's displacement usually. And then here's time. Okay, at first quite high, it can bounce up and down a lot, and then eventually lower and lower and lower. This is the important thing for damping. What's no one, son? Question 15. Diagram 11 shows mercury level of a manometer when connected to a gas supply. What is the value of pressure at point P? Okay, this kind of question, which is the gas pressure, by the way. Yeah, because the gas is pressing down on point P. Okay, this kind of question, I like to say, just look for 2 points that are the same. Look for 2 points that are same level and both also same liquid mercury. Must be same level, same liquid. Both also mercury. Cannot be one mercury, one water. Must be same liquid and same level. So this point 1 and this point 2, they would have the same pressure also because it's the same level, same liquid. Okay. Point 1, you have atmosphere acting on the surface. You also have another 20 cm of mercury acting on the surface. Because down here is 10 cm. Right? They give you 10 cm. So from here to here has to be 20 cm. The whole thing is 30. 30 minus 10, you get 20. Okay, so in that sense, it means that point 1, you have atmosphere pressing on top of point 1. You also have 20 cm, you also have 20 cm of mercury acting. At point 2, it is the gas pressure. Atmospheric pressure, it is 75 cm Hg. Usually it's 76, but this question used 75, we follow. Therefore, the gas pressure is 95 cm Hg. When I say gas pressure, I mean the pressure at point P lah. Because point P is memang only the gas pressure. Yeah, point P is only the gas pressing on top. So you see what is pressing on top of those points? Answer is C. Okay, don't need to memorize one. Just look for 2 points, same level, same liquid, same pressure. Same level, same liquid, same pressure. Question 16. Diagram 12 shows water wave propagate through a small gap. Which of the following characteristics of waves is correct after passing through the gap? Frequency decrease, nope. Wavelength decrease, nope. Speed decrease, nope. Amplitude decrease, correct. Why? Because as it passes through a small gap, it spreads. This is called diffraction. Understand, you got little bit of wave only go in to this tiny gap. After it go in, it will spread and become so big. So little wave go in, but now spread becomes so big. Of course, the energy will decrease. Of course, the amplitude will decrease. Yeah, amplitude decrease means energy also decrease. Okay, but why frequency never change? Why the frequency here and the frequency here the same? Because let's say you have a dipper creating a the wave, the dipper dip, 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 dip like that, and it creates that wave. If the dipper has a frequency of 2, then here the frequency will be all the same one. Frequency depends on the source. Same source, same frequency. Okay, why wavelength never change? Because the speed and the frequency both never change. Speed never change because it is same medium or same depth of water. No refraction. As a good physics student, you have to know only one thing can change frequency, the source. You make the dipper become 3 hertz. Then here 3, here 3, here 3. The source determines the frequency. Like what kind of wave, where the wave come from, source. Okay. The speed can only be affected by refraction. If you change the medium or you change the depth of water, then refraction occurs. Then your speed change. No refraction, speed confirm won't change. In your whole syllabus, only one thing will affect speed of wave. Refraction. Only refraction can change the speed of wave. Okay. F never change, V never change, lambda also won't change one because they're all connected in this formula. I like to rearrange like this. The speed will affect the wavelength. The frequency will affect the wavelength. Yeah. But by the way, the speed and the frequency, they don't affect each other one. V and F don't affect each other. V affects lambda, F affects lambda, but V and F, they are like the manipulated variable. Lambda is like the responding variable at it. Okay, something like that. Okay, question 17. Diagram 13 shows a boy walking along plane RS in front of 2 loudspeakers connected to an audio frequency generator. The boy will hear a loud sound, soft sound alternately. The distance between 2 consecutive loud sound is 2 cm. Okay. What is the wavelength of the sound produced? This is an interference pattern. We look at this interference formula. Lambda equals AX over D. I think the only challenge is whether you know what is the meaning of each symbol. Yeah, we're looking for lambda. They give you the D already. D is from the loudspeaker to where you measure or where you hear the sound. That is the D. A is the distance between the 2 loudspeaker, distance between the 2 source, 2 coherent source. Distance between 2 consecutive sound, that is called X. Okay, so as he walk from R to S, sometimes he hear loud sound. Sometimes he hears soft sound. Sometimes he hear loud sound again. But from loud to loud, that is called the X value. Okay, and it's 2 cm, let's say. Okay, we sub in everything. But guys, you want to get meter, maybe I put everything in meter. The A is 150 cm. That sounds like a 1.5 meter. Okay, that's the A. X is 3 meter, no problem. Sorry, D is 3 meter. X is 2 cm, meaning 0.02 meter divided by 100. So 1.5 meter multiplied by 0.02 meter divided by 3 meter. The wavelength of the sound would be 0.01 meter. Okay, answer is 8. Okay, right, question 18. Diagram 14 shows a light ray being refracted as it enters liquid X. What is the refractive index of X? They give you incident angle and refracted angle. Okay, the incident angle happens in air, which is a good thing. So therefore, you can use this formula. But I also told you all, I told my students many times that you can use this one. You can also use this one. They are the same. Okay. However, sine I over sine R has a rule. You must make sure the I must be in air or vacuum, then only can work. If the incident angle is from water, for example, and then the R is air like that. Okay, the R is the air. The I is the water or another liquid or glass block or what. Then cannot. Incident must be air. Okay, if it's not air, then how? Then you use this one, this version. Yeah, by the way, air and vacuum, they have a perfect refractive index of 1. This one you have to know. Okay, so you can use either one. Both also works for this question. If I do sine I over sine R, because the incident angle happens in the air, I'll get my answer pretty fast, just like this. Okay, some of your calculator requires you to put a bracket, so make sure you have that. Some calculators don't need. Answer would be 1.509. Okay, answer is C. If you do, we call this Snell's law. If you do this version instead, it will also work. Only thing you need to know, air has a perfect refractive index of 1. Okay, so in air, the index is 1. The angle in air is 49 degrees. And 2, I want to find. Okay, this one I want to find. And the angle here is 30 degrees. So therefore, n is still sine 49 over sine 30. Same, okay, same. Then you will get the same answer. Yeah, but Snell's law very useful, and this formula very useful. Useful if they didn't use the index as, sorry, the incident angle in air. Okay, like what if it's terbalik? What if the incident angle is here and then the refracted is here? Then you will get wrong answer one. Yeah, you will get the wrong answer one. So you have to be careful. Some people say, teacher, can I just use this one always? Can also. If you use this one all the time, confirm your answer will be correct. You will not make a mistake. But if you use this one, sine I over sine R, please be careful. Incident angle must be in air. Yeah. Question 19. Diagram 15 shows light ray pointed from water to air through point O. The incident angle of incidence is larger than critical angle of water. Okay, what is the correct path after passing through point O? Donkey. The moment I see I bigger than C, but please double check, sometimes they purposely want to confuse you. You must also make sure that the light is going from denser to less dense. Denser go to less dense. If it fulfills these 2 criteria, then total internal reflection will occur. Total internal reflection. Total internal reflection means that all the light ray, all the light ray, like total means all of it, 100% of the light, gets reflected. Internal means it reflects inside this denser medium. It gets stuck inside the water. Like suddenly this water become a mirror like that. It's stuck inside the denser medium, internal reflection. Okay, it doesn't refract out. It doesn't refract out. Answer is donkey. Okay. Question 20. What happens to the size of the image of a magnifying glass if object is less than the focal length of the lens? If U is less than F. By the way, if you want to get magnifying glass, you must make sure U is less than F. Then only it can help you to magnify the image. Magnifying glass must be U less than F. Okay, so this one is testing to see how well do you know your convex lens characteristics. Let's say we got a convex lens. Let's say this is F. Let's say this is 2F. And let's say this is infinity. Some students, they memorize the characteristics. They say, teacher, I memorize read, wrist, rim, voom, voom. Yeah, read, wrist, rim, voom, which means real inverted diminished, real inverted same size if I put my object here. If you put your object right here, then you get virtual upright magnified. Yeah, right now the object distance, if they say object is here, the U value less than the f value, which is here lah. Yeah, then you're gonna get virtual upright magnified image. Okay, this is for convex lens. Magnifying glass is a convex lens. Okay, concave lens is even easier. Concave lens is all just virtual upright diminished. Okay, and then one more thing, since we are talking about this already, convex lens, the characteristics of image is the same as concave mirror. For concave lens and convex mirror, all the image will be virtual upright diminished. Okay, so concave, convex, convex, concave. Yeah, so you know one for your lens, you will know for your mirror as well. If you don't know these characteristics, then a bit difficult, huh? Okay, we look at question 21. Diagram 16 shows a ray diagram for a compound microscope. Which of the following statement is correct about the ray diagram? The final image form is real and magnified. For magnifying glass, for compound microscope, my bad. For compound microscope, the final image is definitely virtual, not real. How I know? You can tell from the final image. Okay, where's the object? This is the object. This is the first image, I1. The final image is right here, I2. Okay, if it's real, it means that the image will go past the two lenses. You have two lenses, right? It will pass the lens and then pass the lens again. It will reach here. But the fact that it goes behind the microscope, the fact that the I2 is behind the microscope means it's virtual. Of course, it has to be magnified because that's the purpose of using a microscope. Use microscope to zoom in. Okay. And then another one, distance between L1 and L2, distance between the two lenses is equals to FO plus FE. Nope. FO is like this. FE is like that. The distance is not FO plus FE only. There's a little gap in between. It's bigger than FO plus FE. Yeah, the equals to one is for telescope. So wrong again. And then object distance is less than FO. Well, one way to quickly see, right? Even if you use the picture, you can get the answer. FO is this long. You agak-agak, FO is right here. The objective lens focal point of objective lens FO is right here. Do you see your object is further than the FO? Yeah, normally this object is between FO and 2FO. For microscope, it's between FO and 2FO. How I know? Because I've done microscope so many years already. Yeah. Okay, this comes from experience. But so object distance is not smaller than FO. Smaller meaning it will be inside here already. C also wrong. From the picture you can tell. D has to be the correct answer. Thickness of L1 must be greater than L2. Okay, guys, when we say thickness is greater, we are not talking about the size. We're talking about the thickness, which is correct. Thickness also refers to the power. If you have a very thick lens, very thick, the light pass through the thick lens, a thicker lens will bend a lot, will force the light to bend a lot, will refract a lot. A thicker lens have a very, very high power. So it will bend a lot, which also means the power, these two same meaning, power of, not same meaning, they are related. Power of lens L1 will be greater than L2, which is important for a microscope lens. L1 must be bigger than L2. First lens bigger than second lens, the power, because first lens need to look at microscope objects like microorganisms, bacteria, very small things. The power of L1 must be very, very high. Okay, L2 is also quite high, but L1 is very, very high. Yeah, it's a pretty thick lens. Okay, answer is donkey for question 21. Okay, question 22. Diagram 17A, 17B shows two balloons with different size filled with helium gas released to air. Both balloons are stationary in the air. Okay, you fill it with, it's different size, and then you fill it with helium gas, and both are now stationary. When they are both stationary, it means that the weight of the balloon is equals to the buoyant force. Right? And in the question, they say, which of the following statement is correct? Okay, we read through one by one. Weight of balloon increase, buoyant force increase. That's true. If you look at the two balloons, if you have a greater weight of balloon, then you must have a greater buoyant force. So for example, we can put some values in. If the weight of the balloon here is 1 Newton, buoyant force must be 1 Newton, then only can be stationary, right? But of course, you have a smaller balloon for the second picture. It means that maybe the weight of the balloon is a smaller value, let's say 0.6 Newton, which means here also must be 0.6 Newton. Then only you can maintain stationary. Yeah, so that is how it works. So that's right. A is correct. If weight increase, then buoyant force increase. B, volume of air displaced decrease, buoyant force decrease. That is also correct, if you ask me. If it like the smaller balloon displays less air. Yeah, it displays less air. That's why the buoyant force is lower also. That is true. So both also true. Okay, never mind, we see C. Weight of balloon increase, then weight of air displaced increase. Weight of air displaced, according to Archimedes Principle, weight of air displaced is equals to the buoyant force. That is the exact same sentence as A. Weight increase, buoyant force increase. Weight increase, buoyant force increase. C also correct. That's why there's a problem with this question. A, B, C all correct. Yeah, this question got issue. Yeah, A and B and C, they're all correct. I think the question wanted to say to choose the incorrect statement maybe. Then the answer would have been donkey. Yeah, but guys, let's read through donkey. When the volume of air displaced decreases, you displace less volume of air, the weight of air displaced will increase. Confirm wrong. Less volume, of course, less weight of air also. Okay, so D is the only one that is wrong. A, B, C all correct. Yeah, A, B, C all correct. There's no answer for this question. A and B and C all correct. Okay, so you can choose anyone lah. Maybe A or B or C. They're all correct. Yeah, only D is wrong. Okay, so in this case, maybe we just choose one answer lah. It is A. Yeah, but A and C also same meaning, you know. Okay, I mean any one answer, A or B or C, all correct. Okay, question error. So in this case, you just circle anyone. Yeah, they will mark it for you. Okay, question 23. Which of the following situations show the forces in equilibrium? A clock hangs on the wall. Yes, because forces in equilibrium meaning the acceleration must be zero. Acceleration must be zero got two versions. Either it is at rest or cannot be accelerated, acceleration zero, or uniform velocity. So you must make sure you look for these two, at rest or uniform velocity. Cannot be accelerated. Okay, answers 1 and 3. Boy. Yeah. If you are wondering, teacher, why if forces in equilibrium must be A equals to 0? Because equilibrium meaning resultant force is 0. For you to have a 0 resultant force, you must have a 0 acceleration. Yeah, the resultant force must be 0 if it's equilibrium. People always forget the uniform velocity one. Uniform velocity also means A equals to 0. Okay, question 24. Diagram 18A shows a cooling curve, 18B shows a heating curve. Okay, which of the following statement is correct explaining the phase QR in both the picture? Let's take a look. They say all this is either heat released to change kinetic energy or bonds. It's all kinetic energy, and bonds. Okay, at least we roughly know what are they talking about. At Q to R, actually, if you want to put down the state of matter also can. From gas to here is gas slowly become liquid. Yeah, here's liquid only. Then liquid slowly becomes solid, and then here's solid only. So from Q to R, it is gas. Gas become liquid. At this point here, temperature never change. Heat is released because you're cooling down. Heat is released to change gas to become liquid. Gas look like this. Liquid look like this. You're trying to form bonds. But kinetic energy unchanged. Why I know? Because temperature unchanged. Kinetic energy and temperatures, they are best friends, I always say. When one don't change, the other one also don't change. Okay, so for this first picture, QR, I want to look for heat release, form bonds, the kinetic energy never change, temperature never change. By the way, when I say form bonds, it means the molecules stick together. They form together, they stick together. Okay. Okay. Heat released, increased kinetic energy, that's wrong. Yeah, kinetic energy never change. Decrease also wrong. Heat is released, kinetic energy unchanged. That sounds correct. Heat is released to weaken the bond between molecules. If can, normally we will say break the bonds. Yeah, because weaken. Sorry, it's supposed to be form bonds, it's not weaken the bond. You're forming bonds, not weaken bond. So weaken is wrong. Weaken is when you heat it up, not when you release the heat. Okay, so D confirm wrong. Answer has to be C, but let's double check with the second picture. For this one, QR, same thing. From solid, this is solid, become liquid, liquid become gas. This is gas. Okay, at this point right here, you are absorbing heat because you are heating up. Okay, absorb heat, and you are trying to make solid become liquid. We call this weaken bond. They stick together a lot, and then you try to like weaken them a little bit. You haven't totally break the bonds yet because some of the circles, they still stick together. The molecules still stick together. Not like gas. Gas, you break it up. But this one, you weaken the bond. Kinetic energy unchanged because temperature never change. Yeah, it is fixed at the melting point there. So you are not trying to increase kinetic energy. Decrease kinetic energy also wrong. Okay, kinetic energy never change. Heat is absorbed, kinetic energy never change, correct? Heat is absorbed to strengthen the bond. Nope, we're trying to weaken the bond. Answer is C. Okay, answer is C. Yeah, I already know it's C lah. Yeah, but I just want to tell you the full version. Okay, question 25. Diagram 19 shows a siphon used to transfer water from an aquarium. Which of the following statement explains the situation? Okay, they ask us to compare pressure of X and Y. Y must be low pressure. X must be higher pressure. Then only the liquid can flow. Okay, what is the reason why Y has to be low pressure? Because gravity keeps on pulling the water down here actually. Gravity keeps on pulling this water down. And as a result, if you remove some water, it creates a lower pressure region right here. Also at the same time, why this one high pressure is because atmosphere is constantly pressing on the surface. And also you have this depth of water pressing on the surface. sorry, not pressing on the surface, there's some liquid pressure, water pressure acting on point X. So both the pressure press onto point X, it pushes the water and it pushes it up. It keeps on pushing it up, pushing it up. That is how the water flow out in a siphon. Okay, so I want to say X is higher than Y. X is higher than Y. Yeah, answers boy. X higher than Y, or Y smaller than X. Okay, 25 is B. 26. Diagram 20 shows a transistor circuit which is connected to a LDR. When the LDR detects light, the potential difference is 1.2 volts. This guy, 1.2 volts. This is a classic potential divider circuit. Please ignore everything else. Okay, in this kind of calculation, you only focus on this series circuit. Okay, you only focus on this very simple series circuit where the battery voltage is going to split up into two. In a series circuit, current is the same, voltage will share. That means, actually, if I ask you this one at the top here is how many volts, you can just say it is 6 minus 1.2 equals to 4.8 volts, you know. Why? Because 6 volt must be equals to 4.8 plus 1.2. It will share one. Yeah, so this kind of question, normally I tell my students, you write out the ratio. We want to find out the resistance of LDR. 1.2 volt will give me, or 1.2 volt is from a resistance of a LDR. And then 6 volts will give me total resistance. Total resistance is what? We add it up, 10 kilo ohm plus R LDR. If you're wondering why we are writing the ratio of voltage to resistance, that is because according to V equals to IR, when you say the voltage will share, but the current is the same, it means that in the case where current is the same, a higher voltage gives you higher, or higher resistance always gives you higher voltage. So how does the 6 volt share? It follows the ratio of your resistance. Imagine if the resistance is 1 ohm to 5 ohm. How will 6 volt share? Then 6 volt will be 1 volt to 6 volt. That's the idea. We use ratio to answer this. Okay, so in exam, this is how I will write it. 1.2 over 6 equals to R LDR over 10 plus R. Something like that. Normally if you write like that, you can get marked already. Most of the time, 2 marks. Yeah. We would prefer you to write the total voltage and the total resistance at the bottom, if you can. Okay, if you can. And then the one on top there, this one, normally we will write out the resistance and the voltage at the base circuit here, if you can. Okay, if you want to write out the voltage and the resistance for this one, also can, but usually we prefer, if you can, you write for the base. The base is the one down here. So this one, and also the total voltage, total resistance. Then you just write it out like this. Sometimes some people will also write like this, or some mark schemes they will write like that. So either one, both are fine. Okay, and then you go and solve for the value of R. Yeah, up to you how you want to do it. You can cross multiply or what. If you cross multiply, 1.2 multiply with 10, I get 12. 1.2 multiply with R, and then 6 multiply with R. 6R minus 1.2R is 4.8R. 12 divided by 4.8 is 2.5. Kilo ohm. Okay, answer C. Everything is in kilo ohms, this question. Kilo ohm, kilo ohm. Yeah, so kilo ohm here also will be kilo ohm. And guys, don't include the 1 kilo ohm. This 1 kilo ohm not involved in the green color series circuit. This is a potential divider circuit. Okay. Transistor circuits are pretty complicated, but you need to understand this calculation first. This calculation is very popular. They love to ask paper 1, love to ask in paper 2 also. Okay. Question 27. Diagram 21 shows a truck uses hydraulic system to unload sand from a tipper at the construction area. What is the physics principle involved? Well, if it's a hydraulic system, where hydraulic system meaning it pushes the liquid up and all, then it has to be Pascal's principle. At all the Pascal principle application, right? If they ask you lah, can you name a Pascal principle application? You always must mention the word hydraulic. Like for example, hydraulic brake system or hydraulic jack to lift the car up when your tire spoil. That one. Hydraulic is always Pascal principle. To push the liquid, and then the liquid will push it up, and then it will push the piston higher, higher, higher. This is how you unload the sand. Okay, question 28. Diagram 22A and 22B shows a copper coil connected to a galvanometer. The coil rotates between two magnets of opposite poles. Okay, so it keeps rotate. This one 40 rotation, 80 rotation. Which of the following statement is true? Okay. When speed of rotation of coil increase, magnitude of induced EMF increase. Yeah, sounds correct to me. Okay, you spin more, you will get more EMF. Yeah. Distance of magnet increase, magnitude of EMF increase. No, if you increase the distance, magnet further away, then the magnetic field will be weaker. Yeah, that's wrong. Strength of magnetic field increase, magnitude of EMF decrease. If strength of magnetic field increase, the magnitude should increase. Magnitude of induced current decrease, induced EMF increase. Confirm wrong. When EMF increase, current always increase. Our clear winner is A. Okay, I think this question is very obvious. 40 rotations. And then some people might ask, teacher, but why this one, it looks like it is at 0, and then why this one look like a value very high? Because you are dealing with a galvanometer. Do you remember galvanometer in the middle is 0, 1? So actually, if go further away from the center, means it is a bigger current actually. Yeah, this one is a smaller current actually. According to Faraday's law, chapter 4, 4.2, if you rotate faster, you will cut the magnetic flux more. The rate of cutting of magnetic flux will be higher. You cut it faster. When you cut the magnetic flux faster, you get more induced EMF and more current flow. So, okay, a pretty simple one, I feel. 28. 29. Diagram 23A and 23B shows metal-coated polystyrene ball oscillates with between two metal plates of different velocities. The distance between the two metal plates are the same. Which of the following statement is correct? If the distance is the same, let's see, how come the speed are different is because the voltage is different. Okay. When the EHT power supply increase, the number of charge of metal plates decrease. The number of charge on, I think this is supposed to be on the metal plate, decrease. No. If more EHT, then you should have more charge. The number of charge of metal plate increase, the velocity decrease. Also no. Will velocity increase, the strength of, if it's faster, velocity increase, the strength of electric field should be higher. The strength of electric field increase, the number of charge increase. That's right, donkey. Okay, 29 is donkey. When you got higher voltage, your electric field strength will increase. And the number of charge on the plates will also increase. How come the number of charge will increase the velocity is because imagine the ball when it touches this plate, let's say this plate is positive. Okay, positive lah. And then the ball is also positive. If you have a lot of positive charge, it will repel it further. Not repel it further, it will repel it harder, like the repulsion force will be greater. Therefore, it will push it away faster. That's how the number of charge on the plate affects the speed. Okay, so higher voltage, you should have more charge on the plate. Yeah, and also this is related to a formula in chapter 3. This one, this number 2. Okay, E is electric field strength, V is voltage, D is the distance between the two plates. Yeah, so the question is saying if you increase the V, you will increase the electric field strength. Yeah, increase the V, increase electric field strength. More electric field strength, more charge means move faster. Okay, question 30. The diagram shows an electric circuit. What is the internal resistance of the circuit? Okay, internal resistance only got one formula. Only one formula only. That is this, number 7. Internal resistance is the small letter r. Yeah, you see all the other formula don't have small letter r one. Okay, so we got e.m.f. We got the current. e.m.f got, current got. I want to find small letter r, but the v I don't have. They give you the r though, the big letter r though. Okay, but v is the same thing as IR. V equals to IR. So you can rewrite your formula like this. Yeah, or some people, they will go and write it like this. They will factorize the current and then they write it like this. Okay, but we can solve already. Current is 0.7. Big letter R is 4. Small letter r is what we want. This is 2.8. Okay, so 3 minus 2.8, 0.2. 0.2 divided by 0.7, that's the answer. 0.2857 ohm. Okay, so normally they round off 2 decimal here, 0.29. Okay, question 30 is A. Again, question 31. The diagram shows a specification label on a washing machine. What is the electrical energy usage by the washing machine in 0.5 hours? Okay, the two labels are the same. One is in English, one is in BM. They give you the voltage, the hertz, the power, and all. Okay. Be careful. The units are all in kilowatt hour. Electrical energy is E. This is time. The info that you have here is things like voltage and power, but those of you who have done this a lot, you will know you have to use power to get it. Even if you don't know, you look at the unit, got watts on, kilowatts. Confirm you need to use the power. Okay, so I want to find energy and then got power, got time. What formula do we use? It is this one. Got power, got time, want to find energy. Normally, we like to say E equals to P multiply with the T. E equals to PT. Okay. Just that if you want to get kilowatt, make sure you don't sub 600. You sub 0.6 kilowatts. Yeah, if the time you want hour, you leave it as hour, 0.5 hour. You don't change to seconds. So don't use SI unit. Then you get 0.3 kilowatt hour. Answer is C. Okay, answer is a C. Can. Kilowatt hour, very useful if I want to find out the electricity costs. The electricity costs, they use kilowatt hour to find one. Okay, question 32. Diagram shows the catapult field formed when a current carrying conductor is in a magnetic field. Which of the following factors increase the magnitude of the force? Increase the F. Okay, normally if you want more F, you need to have more B and more I. Yeah, you want more F, you need to have more B and more I. Increase the current. Correct. Increase distance between magnet. Wrong. Magnet further, meaning magnetic field will decrease. The B will decrease. So B is wrong. Decrease diameter of the current carrying conductor. If the conductor, the wire, the conductor is that piece of wire. If this wire is thinner, diameter decrease, thinner, meaning the cross-sectional area of the wire is very small. Therefore, the resistance is very high. High resistance meaning low current. I don't want. A thin wire, very hard for current to pass through. And we don't want that. And if you use longer wire also, the resistance will increase. So less current flow. Okay, I want A. More current, more force. Because stronger interaction of magnetic field. Yeah. By the way, this one is Fleming's left-hand rule. You use Fleming's left-hand rule to find out. Question 33. Which of the following shows the similarity between the working principle of a direct current generator and alternating current generator? Okay, both generator, but what is a similarity? Slip rings are always connected to the wrong. A DC generator uses a split ring commutator that look like this. The ring is split into half. Alternating current uses slip rings, where the rings are two separate rings like that. Yeah, so that is the difference. The ends of the coils are connected to two slip rings. No, that's not a similarity. The coil is rotated by an external force. That is a similarity. The output is alternating current. Wrong. People already say this is direct current generator. Yeah, so this direct current generator will give you direct current. The alternating current generator will give you alternating current. The output is different. Okay, but both of them, if you want to generate electricity, you want to get current, both of them must have a force to rotate it. Both of them must have magnetic field. Then only you can get the current. Then only you can induce the e.m.f, induce the current. You need to have force and magnetic field. When I say force, it means you need something to go and rotate. You need to spin it to cut the magnetic flux. Yeah. Okay. Question 34. Which of the following characteristics increases the efficiency of a transformer? Transformer, answer C. If you use long nichrome wire, you increase the resistance. Long wire increase resistance. Nichrome, very high resistivity. We don't want. We want to reduce the resistance as much as possible. Yeah. So all this is related to how well do you manage so that we don't keep on wasting the energy in the form of heat usually. Anything high resistance will keep on producing heat. Heat is useless in transformer. Transformer don't want heat on. Transformer is not trying to become a bread toaster or hair dryer. Transformer is just trying to step out or step down the voltage. So any form of heat, remember, in a transformer is useless. So thin wire also same thing, useless. It will make it very hot. Yeah, thin wire, very high resistance. A solid soft iron core, laminated soft iron core. Okay, a solid soft iron core meaning like this. A laminated iron core meaning like this. The difference is if you use one big block like that, eddy current can form very easily. All these are called eddy current. Eddy means a spinning current, like a swirling current, a circular current. All this current, right, is produced because the magnetic field keep on changing direction. You know, in the transformer, you have alternating current, got changing magnetic field, and it starts to produce all this eddy current. Eddy current is useless one in a transformer because it only makes it hot. Yeah, but if you have laminated, meaning very thin sheets of iron core, very thin sheets of iron core like this, then eddy current will be very difficult to form. If form also will be very small. Yeah, very difficult to form because the iron is so thin, very hard to form. So it will barely form, but even if it form also a little bit only, and quickly it will disappear. So you won't produce a lot of heat as a result. Yeah, very hard to form the eddy current. Yeah, reduce eddy current a lot. Answer is C. Yeah. 35. Diagram shows a full wave rectification circuit. Which of the following is correct for P and Q? Now, a full wave rectification is trying to change a AC that look like this to a DC that look like this. This is full wave rectification. Okay. Now, for you to do this, you have to make sure that your diodes must be connected correctly. I always say, when I teach my students, I always say, the opposite diodes must be same direction no matter what. They must be pointing the same way no matter what. Okay, so these two, they are both pointing the same way. Okay, now P and Q both must be pointing the same way. The question is, are they both pointing like this or the other way around? Well, when current flows, let me move this away. Yeah. Alternating current means current will flow like that. Then afterwards, current will flow like that. So it keeps changing direction. You just make sure as current flow like this, one of them will block the current flow. And in this case, this guy will block the current flow because it's opposite arrow. If the arrow is opposite, the diode will block the current from flowing. And the other one must allow the current to flow, meaning P must be like this. Okay, one must block, one must allow. And the opposite diodes must be the same direction. These two has to be pointing the same way. Therefore, the answer must be A. Okay, the answer must be A. Both must be pointing the same way. Now you might ask me, teacher, what if the current flow from down here? Same thing. One will allow the current to flow. One will block the current from flowing. Okay, so that's what AC means. AC means current will flow up and then current will flow down. Up and down, up and down. And it keeps changing, it keeps alternating until it is, or not until, it keeps changing direction 50 times in a second. Very, very fast. Yeah, that's how it works. Of course, I can also show you if you're interested to know, teacher, how does the current flow through the whole circuit actually? This is how it works. It will flow through here, and then it will flow through the resistor because this one will block the flow. And then it will flow through like this, and then it'll pass through this bump. Okay, so remember just now this one will block the flow already, right? Don't say, teacher, why cannot flow like this? If just now blocked already, now it will also block the flow one. And now it will also block the flow. So which means the current has to pass through from here. Okay, the current has to pass through from here, and then it must come back. This is how the whole thing works. It flows one round and come back. Okay, it flows one round and come back. You might ask me, teacher, why just now it never flow like this? Hey guys, it cannot flow like this and then flow backwards. Tak boleh. It must flow down and come back one. Must go one round and come back. Don't get lost, don't go and then don't know how to come back. Must go and come back. Yeah. And also, just now, if here block already, as it is flowing, if here block the current just now, afterward when it flow, it will also block. It won't suddenly allow it to flow one. That's why full wave rectification always, it will flow through the two opposite diodes only. Yeah, right now it's just these two opposite diodes. These two will block. Then afterwards, it will change. When current flow the opposite way, it will allow the flow here, it will block the flow here. Right? Cannot go here. It must go this way. And then here, can I continue to go this way? Cannot, because the diode will block it from flowing. It will block the flow. You are forced to come down here. Okay, just now here already blocked. Now still blocked. It has to pass through this one and come back. My point is, you will see, this time it will pass through this and this diode. It will always pass through the opposite diode. Opposite diode must be same direction. Okay, I'm teaching you all a little bit more than what the question wants. Yeah, I'm doing a bit more revision a little bit, but just don't forget, opposite diodes must be same direction. And just make sure one will block the flow, one will allow the flow. You can go from the bottom or go from the top, it doesn't matter. One will block, one will allow the flow. Which one allow, which one block, doesn't matter. But one will block, one will allow the flow. Okay, question 36. Diagram 28 shows an incomplete path of a cathode ray. Which of the following is shows the correct path of cathode ray when the EHT is switched on? This is asking whether do you know cathode ray is electron beam. Okay, cathode ray is a fast-moving electron beam. That's it. And if it's an electron beam, it will definitely be attracted to the positive plate. So it will bend up. It will be deflected up. Answer is boy. Donkey is the funniest one. Yeah, it will definitely bend up. Negative attract to positive plate. Okay, question 37. The diagram shows a graph obtained from an experiment. Which of the following represents the amplification factor? Formula sheet tells you amplification factor. This one. Okay, amplification factor. IC over IB. Collector current over base current. Okay, collector current over base current. To get this, you have to do the gradient of the graph. Why? Because the collector current is the y-axis. The base current is the x-axis. When you do y divided by x, you are getting gradient. Okay, for a directly proportional graph, y divided by x is always the gradient, because you think gradient normally is y2 minus y1 over x2 minus x1. It's always y divided by x. Yeah, area definitely wrong. IB over IC also wrong. Because why is area wrong? Because area you are taking IB multiplied by IC. I don't want. I want IC divided by IB. Yeah, and amplification factor is not the IC value as well. Okay, so formula sheet will also remind you it has to be gradient. Let's see. Okay, question 38. The following equation shows the decay of element X. Which of the following are the characteristics of the ray produced from the decay process? This is a gamma ray. This is a gamma decay. Gamma ray. So they're trying to ask you about the characteristics of gamma ray. Gamma ray, unlike alpha particle and beta particle, gamma ray has no charge one. Gamma ray is just a wave. It's neutral one. Like the helium nucleus not helium atom, helium nucleus is positive 2 charge. Because why? There is 4 nucleons, 2 protons. 4 nucleons, that means got 2 proton and 2 2 proton and 2 neutrons. 2 proton meaning it is positive 2 lah. And then this one, the charge is negative. This one, no charge, neutral. It has no mass because it is a wave. It is fast-moving electrons, also wrong. That is beta. It's a high-frequency electromagnetic radiation. That's right. Gamma ray is memang electromagnetic radiation, electromagnetic wave. Yeah. Answer is 1 and 4. Donkey. Okay. Next one. Question 39. The diagram shows a graph of decaying curve of a radioactive substance. Oh, based on the graph, what is the half-life of the radioactive substance? Okay. The half-life is the time taken for it to become half. It doesn't matter what number do you begin with, but just time taken for it to become half. And they purposely do a bit K-bar. They start from a random value, which they didn't give you, but from 120 to 60, that is half. When the activity becomes half, or the number or the mass becomes half, that time taken to become half is the half-life. And that sounds like 60 seconds. Half-life is this. This is the symbol. Not 60 seconds, sorry, 60 minutes. Okay, can from 20 to 80 here, 60. That is 60 minutes. Answer is C. Okay, question 40. Diagram 31 shows 2 circuits of photoelectric current production by photocells coated with cesium and lithium. Okay, which of the following is correct? So they gave a bunch of stuff like work function is different, threshold frequency is different, and maximum wavelength to produce photoelectric current is different. Okay, so the idea is if you want electrons to be emitted from the cathode surface, from the cesium surface, from the lithium surface, you must make sure that your energy is higher. The light energy is higher than the work function. Work function is the minimum energy you need to bring the electrons out, to emit the electrons. Yeah. You also must make sure that your light frequency, or this is about the light, light frequency must be higher than threshold frequency. Okay. But there's also such a thing as maximum wavelength. You must make sure that the wavelength of your light must be less than the threshold wavelength. All these are called threshold wavelength actually. Okay, there's like a maximum wavelength. Yeah, you cannot go any higher than that wavelength. Then only electrons will be emitted. Guys, all these are talking about the energy of the light, the frequency of the light, the wavelength of the light cannot be too long. Must be shorter than there's a maximum. Then only electrons will be emitted. Okay, they ask which is correct. As the work function increase, maximum wavelength increases. Wrong. Oh yeah, by the way. Okay, so this one is talking about work function and maximum wavelength. This is talking about threshold frequency and work function. Maximum wavelength and threshold frequency. Last one is light intensity and photoelectric current. If light intensity increase, photoelectric current will increase. So D confirm wrong. But I just wanted to show you, right, all this actually related to a formula in your formula sheet. Work function, this one. Work function is Planck's constant times FO. But the FO, you can also write it as like this. FO is equals to speed of light divided by lambda O also. So FO, you can write it as C divided by lambda O. So there's two formula for work function actually. HFO or HC over lambda O. Okay, now I just want to show you how to see this. And then it becomes super clear. HFO, HC over lambda O. When W increase, They say lambda O also will increase. That's wrong. If this one increase, this one should decrease. A is wrong. When threshold frequency increase, work function increase. That is correct. Okay. As maximum wavelength increase, threshold frequency decreases. That's wrong. Why? Because frequency and wavelength is always inversely proportional. You can look at this one. Frequency and wavelength is always inversely proportional. F equals to C over lambda. I know they're talking about threshold, they're talking about maximum wavelength. Maximum wavelength increase, threshold frequency supposed to decrease. So C also wrong. Yeah, and by the way, light intensity meaning the brightness. If you shine a very bright light with a correct frequency, then a lot of electrons will come out. A lot of electrons will be emitted, meaning a lot of photoelectric current, a lot of current will flow. Not the current not supposed to decrease. Okay, I think overall this paper is quite okay and quite a good paper. There isn't a lot of mistake, just one question. Yeah. Okay, I'll see you on the next one. Good luck.